Hello, everyone. Welcome to today's session here at Reinforce. So we're going to be talking about how you can automate patch management and compliance using AWS. So just to get started, my name's Eric Weber. I'm a Senior Specialist Solutions Architect here at AWS, focusing on our cloud operations. So helping customers on those day two operations, after provisioning their resources, you need to start thinking about how you can operate at scale across all of your accounts and regions, as well as maintaining compliance and governance at the same time. So like I said, I've been with AWS a little over 6 years now. I started as a premium support engineer, briefly was a technical writer for AWS Systems Manager. So hopefully there's documentation that you do enjoy that I wrote. If there's documentation you don't enjoy, that was a different author, don't worry about it. Previously, before AWS, I was a systems admin and then also worked on a help desk. I just recently moved into southeastern Pennsylvania. I used to live down in Northern Virginia. And a couple things about me. I recently went to a wedding in Colorado about a month ago now. And at the after the reception, they had llamas that were carrying beer in packs on the side. So that was probably the most unique experience at a wedding that I've had. Bottom right is my wife and I. We're very avid travelers. We have a dog as well. So we're always on the move between these events and then our own personal trips. I also have a son. He's 2 years old. He's always bright and smiley. That picture of him is the first time he saw a roller coaster, and he was just so ecstatic about it.
Good afternoon, everybody. My name is Anya De Velta. I'm a Senior Specialist Solutions Architect, also on the Cloud Operations team. I focus on configuration, compliance, and audit. I've been at AWS for just over 3 years. Prior to this role, I was a public sector solutions architect working with UK customers. In my past life, I come from an operational background. I was a platform engineer as well as a DevOps engineer. I live in the UK, in the Northeast. I don't know if anybody from the UK is here today. And this is a picture of me and my family. We love to travel. This is us in Mallorca. And also, people call me a crazy cat lady for some reason. But I equally love my dogs, so this is my family.
So enough about us and our intros. So just to give you a quick idea of what the agenda will be for today, we're going to start with an overview of AWS Systems Manager, which is a tool that you can help stand up operations across your accounts and regions. We'll then be focusing on the patching side of Systems Manager and how you can leverage it. Then we're going to be moving beyond just a single account, single region, start talking about how we can operate at scale across our accounts and regions within an organization. We'll then talk about the reporting side of it, of course. It's not just about performing the scan or install, but actually being able to report back. Following that, we'll provide a sample architecture, and we'll actually go into the console as well to take a look at it and what it actually looks like once you could set it up. So with that being said, I'll go ahead and hand it off.
Thank you. So Systems Manager is a secure end-to-end management solution for hybrid environments. But in terms of benefits, Systems Manager lets you shorten that time to detect problems. So for example, you can quickly group operational data in groups of resources. You can group that by applications or application layers or environments like production vs development or anything else that you choose. The operational data for your resource groups is displayed in a single, easy-to-use dashboard, so you don't have to navigate away to any other AWS consoles. So for example, if you've got an application that uses Amazon EC2 instances, Amazon S3, and Amazon RDS, you can create a resource group, and then you can then easily see what software is installed on your Amazon EC2 instances, any changes to your S3 objects, or if a database instance is stopped. Another benefit is the easy-to-use automation. So with automated playbooks, with rich text descriptions, you can reduce that human error, and you can simplify maintenance and deployment tasks on your AWS resources. You can use predefined automation runbooks or playbooks, or you can build your own, where you can define and share common tasks such as stopping and starting EC2 instances. And also Systems Manager has built-in safety controls, so it allows you to incrementally roll out your changes, but you can also choose to automatically hold if errors occur. Systems Manager also helps you improve visibility and control, so you can view detailed systems configurations, operating system patch levels, software installations, application configurations, etc. And you can view these in Systems Manager Explorer as well as the inventory dashboards. Systems Manager is also integrated with AWS config so that you can easily view changes across your resources that occur over time. Now, oh, apologies, sorry, I got a problem. Sorry about that. Okay, if I just go back to benefits, Systems Manager, with Systems Manager, you can view resources or servers that are running on AWS as well as in on-premises data center. And you can see that in a single interface. So Systems Manager securely communicates with a lightweight agent that is installed on your servers. And then you can execute management tasks and helps you manage your Windows or Linux resources on AWS as well as on premises. And another benefit is that you can maintain security and compliance by scanning your instances against your patch configuration or custom policies. You can define patch baseline, maintain up-to-date antivirus definitions, or enforce firewall policies. You can also remotely manage your servers at scale without actually manually having to log on to each server. Now, in terms of features, Systems Manager is broken into 3 different categories. We've got ITSM, application management, and a node management. With ITSM, you have features such as Explorer, which is an operational dashboard providing you insights across your AWS accounts and AWS regions. With application management, those features help you manage and operate your application resources in the contents of those resource structures. With features such as app config, you can create, manage, and deploy application configuration changes at runtime. You could automatically roll back changes in case of errors, and you can toggle new application features that require deployment in a timely manner. Now with node management, that gives you the tools and ability to perform those day-to-day activities to maintain your environment. So with Fleet Manager, for example, you can edit Windows registry, or you can have a look at CPU metrics for that node. Now, automation is a key feature of Systems Manager. It works across Systems Manager capabilities. It lets you eliminate those manual errors. And you can write repeatable runbooks. You can invoke them from Event Bridge rules or maintenance windows or state manager associations or change manager and many more. And then with Quick Setup lets you set up Systems Manager features easily, but we will cover Quick Setup in a couple of slides. Okay, so we're going to start with the Systems Manager agent. So the Systems Manager agent lets you remotely manage any node, and that could be an Amazon EC2 instance. It could be devices running at the edge using AWS IoT Greengrass. It could be on-premises or other cloud servers and VMs. The agent supports Linux, macOS on EC2, Raspberry Pi, and Windows Server. The agent's also pre-installed on a variety of AWS-provided AMIs. And then for anything else, you can use automation. So for example, you could build it into your golden image, or you could use user data and install the agent on launch. And Systems Manager agent is also open source. The link is there if you want to have a look. It's on GitHub. So if you're ever curious about what operational task or what's happening, what's running within the agent, you can have a look at the code there. Okay, quick setup. So quick setup is a systems manager's capability, and it is intended to get you set up quickly with various services so you can set up those organizational best practices. You can do this from a single account, or if you do this from your root organization account, you can deploy quick setup configurations across your AWS organization, so across account and cross regions. There are 6 quick setup options available. For example, as well as Systems Manager Host Management, you could deploy sample conformance packs across your organizations. In terms of host management, you are able to track how many environments your quick setup is deployed to. It will show you if there's drift. And also, if you've deployed it into AWS organizations, if new accounts get added, then that configuration will be deployed to new accounts. So with host management, you can configure options such as automatically updating Systems Manager agent every 2 weeks, collecting inventory from your instances every 30 minutes, or also scanning for missing patches daily. In addition, and as an option, if you would like to install, configure, and update the CloudWatch agent using the host management quick setup, you can do that as well. Okay, moving on to patching on AWS. So in general terms, we're gonna automate our patching operations by defining a criteria or types of updates that you want to scan or install. Once we have that criteria, we can start scheduling our patching operations on routine or regular basis as per your requirements. But then outside of irregular patching windows, you can leverage patch management to remediate those zero-day vulnerabilities. After your patching operation has completed, you can then aggregate patch compliance data across all your accounts with resource data syncs to have an idea how compliant your managed instances are across your entire AWS organization. Now, to define patch criteria, you can you can patch your fleet to different levels by defining a patch baseline. You can leverage the default baselines that are available, or you can build your own patch baseline and define that criteria within them. So for example, you can specify classification severity. So say you only want to install critical or important patches. You also have a choice of auto approval options. So you can approve patches after a specified numbers of days after they have been released, or you can specify a cutoff date. So why this is useful? For example, if you're patching on first, second, and third Saturday of every week across your different environments, say QA, UAT, and production, but you want to ensure that you have the same criteria and the same set of patches across all environments. By specifying that cutoff date, you've got the same set of patches, no matter which Saturday that patching operation has taken place. Now, for Windows as well as Microsoft operating system updates, Systems Manager supports Microsoft application updates, such as Microsoft Office, SQL Server, Microsoft Exchange. For Linux, you can install non-security related patches in addition to the OS security patches. Also in Linux, you can specify an alternative repo, and this will override the OS setting during the patch operation. And for Windows, we respect whether you are pointing out to Microsoft public catalog or you have an internal WSOS. So in addition to this criteria, we can also include an exceptions list of exclusively approved or rejected patches. So if there are any updates which interfere with your application, you can always add them to the exceptions list. So when you're ready to run some patching operations, whether that be ad hoc or on routine basis, you're going to be leveraging two different documents. So that's AWS Run Patch Baseline or AWS Run Patch Baseline with hooks. The parameters of these documents can vary, but in general, you can specify an install override list. So for example, if you're installing patches to resolve zero-day vulnerabilities, you can provide a YAML formatted list, which specifically defines which particular patches you want to install during that patching operation. There's also flexible reboot options so that you can choose to reboot after the updates have completed, or you can choose to defer to a later point in time. You can centralize the output of your patch execution logs to S3, or you can export them out to CloudWatch logs. And by leveraging that Run Patch Baseline with hooks document, you can implement multi-step custom patch processes. So for example, you can opt to stop an application before patching occurs if you know that there's going to be issues with that. Or you can update an app immediately after an update, or after the reboot has been performed and the instance comes back up. You can verify and start up your services and applications.
All right, awesome. So once we have that initial criteria, we're performing or defining what type of updates we want to look for, and then we can start thinking about operating at scale across our accounts and regions. And to do that, we can leverage the Systems Manager capability automation. So automation, the capability itself, you'll be hearing the term documents or runbooks. They're pretty synonymous. Runbooks is probably a more commonly heard term that you may be a little bit more familiar with. Creating these well-defined documents or runbooks that are going to perform a series of steps and potentially branch according to what is happening. When we're thinking about these runbooks, again, the intention is that we're trying to eliminate manual tasks from being taken. So within automation, we have over 300 AWS provided runbooks available. So you can get started quickly. The screenshot on the right just shows a handful of them. But when we are working with these runbooks, we can always review the underlying code. We can see the content. They're going to be written in JSON or YAML format. So you can always see what specific actions are being taken. Additionally, for any of the AWS provided runbooks, you can always go ahead and just copy it anew. So if you do need to modify them or add some additional actions, you have that flexibility. Additionally, working with these runbooks, again, help reduce that potential for human error. Additionally, there are some integrations with other AWS services, such as AWS Config. So over in Config, if you're not familiar with it, it's going to be recording configuration states of your AWS resources and establishing some compliance around it. So an example being, let's say in my environment, I want to ensure that S3 buckets are never made available publicly. So within config, I can build out a config rule that is going to monitor my S3 buckets. If any of them are ever made available publicly, I can include a remediation action through automation to go ahead and remediate that and bring it back into a compliant state. So config can stand up these preventative guardrails that are going to go and bring resources back in line with what your expected configuration states are. Additionally, these runbooks, like I mentioned, they can branch accordingly. So when we are talking about patching EC2 instances, there's certainly going to be workloads that are in a stop state. Some of them are actually running. Maybe our development environments, we stop them overnight and then start them back up in the morning. So when we are working with these runbooks, they can branch according to the specific state that the current resource is in. So if my EC2 instance is stopped, let's go ahead and start it. And then we kick off patching and we return it back to that stop state. And then lastly, some other things to highlight is that when we are working with these runbooks, we can also just include Python or PowerShell code directly. So if we need to interact with public endpoints or just it's easier to write in code sometimes, we can just include some script actions that can go ahead and perform some of those steps for us. And we'll actually see that later on as well. And then the key thing with working with automation for this purpose of our conversation today is that it has multi-account and multi-region functionality. So it's going to be through a series of IAM roles that need to be deployed out. But once we have these roles in place, then we can go and kick off a runbook from our central account or delegated administrator. And then we can go ahead and invoke that workflow in those downstream accounts as needed. So talking about that multi-account a little bit further, like I was mentioning, it requires two different IAM roles. So the first is going to be called the administration role. So this is going to exist in your centralized account. And then the alternative is going to be the execution role, which exists in each of those target accounts, wherever our workloads are running, that we want to push these operations into. So of course, you can use CloudFormation stack sets to go ahead and deploy out these IAM roles across your environment as required. And when we are talking about which accounts or workloads we actually want to target, we can specify either the literal AWS account ID, or we could also specify the organization unit. So when you are working in AWS organizations, depending on how you have your OUs broken out, there may be a series or a handful of AWS accounts or hundreds of accounts within a given OU. So we can specify that instead of having to write out each of our account IDs. And then lastly, because we are working with IAM roles, if you do have accounts that exist outside of an organization, you can also include that as well as part of your overall targets. Again, just assuming that you have your IAM roles in place, because it's all just based off of trust relationships with that centralized account. And beyond just the account level, once we have our patching operation being invoked there, we then need to think about which EC2 instances we actually want to target. So in that case, we can filter our resources based off of resource tags that are added or based off of resource groups. And after we perform the operation, we then need to go back and report on it and start being able to share this information out, whether that is to your security teams, to leadership, being able to send out that we are all compliant, or our patch operation just completed, here's what we installed. So thinking about that, there's a couple different ways. Like everything in AWS, we provide these building blocks. So the information that you need to obtain can be found as needed. So when we are first talking about it from a high level overview, getting just a sense of, are my resources compliant or not, we can aggregate this information in Systems Manager Explorer. So Explorer is a high level operations dashboard that's going to collect information from patch. It'll highlight which of your EC2 instances are actually checking in with Systems Manager versus those that are not. Because if you have resources that are not checking in, that means we're not patching them. We're not able to keep them compliant. So we want to identify those and begin to remediate those as well and bring them back in line. Additionally, if we're looking for some more detailed information, we want to be able to identify what updates are going to be installed or what updates were just installed, being able to provide some filtered and detailed information. We can aggregate this data across our accounts and regions using what is called a resource data sync. So a resource data sync is something that you would deploy out into each account and region where you have these resources residing. And it'll take the information from Systems Manager and then export it out into an S3 bucket that you identify. So again, we can have all of our accounts, all of our regions flowing information into this central S3 bucket. And these, what will be placed in the bucket are just JSON objects for each of these managed instances. So what that means is that if you do have third-party tools or solutions that can ingest JSON, query it, filter it, of course, you can go ahead and get started with those. In the context of AWS services, we would be working with Amazon Athena, as well as QuickSight, to be able to query as well as visualize this information. And then lastly, when we are talking about reporting, depending on the purposes of the conversation, you may need to also go back for auditing purposes. So being able to identify, 30 days ago, a month, 2 months, 6 months, whatever that period may be, we would have to be able to go back and report our compliance state. So to do that, again, we can leverage AWS config, which is what I was mentioning earlier. So in config, we have some patch compliance rules. We have a wide variety of other AWS provided rules that you can go ahead and use for your configuration compliance. But when we are talking about the patch side of things, we can be able to go back into the resource timeline. We can see exactly when the resource fell out of compliance, meaning there are updates that are marked as missing, as well as when it was eventually brought back into compliance, whether that's through our routine patching process or through some of these emergency ad hoc operations. So kind of piecing all of these things together now, bringing it a little bit into scale or into scope as far as what this looks like within an organization. So I have the diagram up on the right. Don't worry about it too much at the moment. I have it blown up on the next slide, so we'll kind of walk through the diagram at that point. But just from a high level sense of what this diagram ends up showing is we're going to be scheduling these operations using Event Bridge, cron or rate-based expressions, defining how frequently you want the install or scan to occur. It's going to invoke Lambda, which is going to make our API call for that multi-account, multi-region automation. Again, just defining if we want to scan or install, specifying those resource tags or resource groups, and then centrally aggregate that information again through that resource data sync. So in the bottom right, the QR code is going to be a link to a GitHub repo where we have these sample architectures available. So there are some CloudFormation templates that you can use to get started quickly, try it out, see how it functions for you, and potentially implement at a wider level. So with that being said, like I mentioned, here's a blown up version of the architecture diagram. So just to kind of walk through it again really quickly, we start off with our Event Bridge rule. Let's just say once on every Saturday, let's go ahead and kick off an install, or maybe on the second Tuesday of the month, kick it off. Following that would be the invocation of Lambda, which is just going to make our API call for automation. Specifying here are those account IDs, or here is that OUID list that I want to target, as well as the regions themselves. Once we define that, automation will handle the rest. It'll go ahead, invoke that operation in those downstream accounts, and then kick off patching, whether that is the scan operation or the full install. After those processes complete, again, that information is reported back to Systems Manager and then dumped out into that S3 bucket through that resource data sync. And like what Anya was mentioning earlier, again, Systems Manager and the agent, it extends beyond just EC2. So if you do have it installed in the on-prem, other cloud, wherever it may be, we can also include it within this overall workflow or just any other remote operation that we may need to perform. And once we have that data in that S3 bucket, then we can go ahead and query and visualize it for reporting purposes. So with that being said, let's go ahead and flip over into the management console and we can take a look. Oh, sorry, wrong button. That one. There we go. So first, this is just the GitHub repo that I was just mentioning. So again, you can go here and review the sample CloudFormation templates to see what is actually going to be deployed. This also includes instructions on how to go about deploying it, of course. So there's some detailed documentation available. So flipping over into the management console, I'm going to start just within a single account, single region for now, and then we're going to build up quickly into that multi-account diagram that we were just taking a look at. So I've logged into the Systems Manager console. I'm within Fleet Manager. For those that are not familiar with Systems Manager, this is where we can see which of our EC2 instances or those hybrid devices are checking in and registered, so ready to be able to accept these remote operations. So in here, I have a series of Windows and Linux resources that are checked in. So that means that I can go ahead and perform patch scans or patch installs. And building on that a little bit further, I flipped over into the Patch Manager console. It'll provide some insight to me and as an individual account and region. So I can see again that instance management, how many of those instances are actually compliant with that criteria, as well as how many are actually missing patches and need to be rebooted. So like what Anya was mentioning, when we are working with Patch Manager, the core concept is really going to be these patch baselines, which are defining the criteria of the types of updates that we want to scan or install for. So taking a look at that just for a brief moment, before we actually perform the patch scans and installs, you want to just make sure that we are looking for the appropriate types of updates. So in here, we could always build out that classification and criteria. Let's say that I wanted security and bug fix, as well as specifying that I only want to install critical as well as important. And then just again to reiterate that auto approval delay and the cutoff is critical for environments where we are performing these operations at different intervals throughout a given cycle. And once we have, again, this criteria, then we can start talking about that multi-account side of things, or at least just perform an invocation within one of our accounts and regions. So to do that, I'm going to flip over into my central account now. So let's start off with just the overall AWS organization that I'm working with. So in here, just a very basic organization. I think I have about 6 accounts in total that are just broken up into individual OUs. So like I was mentioning, when we work with automation, we can specify either these OU IDs directly, or we could drill down further into the individual account ID and specify that as well. And you can always mix and match. So if you know a given account just should be included within an OU, we can specify that as part of the operation. So let's navigate first to EventBridge. And we'll pull up the rule. Oops. So in here, for those that are not familiar with EventBridge can either just perform actions on a routine basis, cron or rate-based expression, or we could also kick this off as a result of an event that is occurring within our environment. So an event could be, some of our resources are even just marked as non-compliant for patching. We need to kick off a remediation workflow. Again, whatever is appropriate for your environment. But beyond that, like I said, we're just going to then invoke a Lambda function. So flipping over into Lambda. In here, we have that Lambda function that is going to perform the API call. If we take a look at this, our configuration details are really just stored as environment variables. So in here, you can see which accounts that I am currently targeting. I'm spanning this across 3 accounts and then 2 different regions, US East 1 and 2. When we are targeting these account region pairs at scale, we also need to think about the concurrency that we're running these at. So in this scenario, I have 3 accounts, 2 regions, so 6 total account region pairs. I am just running those 3 at a time, so 3 of them can concurrently start, and then 3 of them will wait first in, first out. So not to spend too much time on the code itself, because that isn't as important, but again, just to highlight, if we were to just take a look down here at the bottom, we're really just making that start automation call to go ahead and kick off multi-account, multi-region, and then using those parameters from those environment variables. So because we're not going to wait just for that next cron invocation, I can just hit test now. This is going to kick it off, and it's going to start that automation operation. So flipping over into that, if I refresh this page now, we can see that the automation workflow has started based off of those parameters that were identified. If I were to scroll through here, then I can see some of those account region pairs. Again, I'm running it 3 at a time. So 3 account region pairs are going to perform patching, and then the remaining 3 will just wait first in, first out. As soon as one completes, another one will then go ahead and start. So in here, I'll just go ahead and drill into one of these. So in one of my secondary accounts, one of those regions, I can see which one I'm currently drilled into, what is that remote region that I'm looking at. And if I scroll down, I can then see that the patching operation has completed. So in my case, I'm just performing a scan. And I've ran these several times today to make sure everything is in working order. So it completed very quickly. It already knows exactly what's missing. But if we were to need to change this, we could always go back into Lambda and modify those environment variables to say, go ahead and install instead. So this is going to update that function, and then I could always go ahead and kick off another test event. So this is going to slowly work through all of those account regions. If there are updates that are missing, it'll go ahead and remediate those based off of the criteria as defined in those baselines. And again, once this completes, then we would have that information flow through that resource data sync into our S3 bucket. So over here, this is the S3 bucket where I am pointing everything to. It's all just based off of a bucket policy. So as long as we are allowing those other accounts access to the bucket, it can go ahead and place objects here. So beyond just what we're talking about today for patching, It can also aggregate other information that may be immediately relevant, such as what applications are actually running on my resources. We can also gather information about drivers that are in place, a little bit more relevant for the Windows workloads, and then other details such as networking information, tags in general, and billing information. So when we look into any of these inventory data types, they are going to be broken out by the account ID, followed by the region, and then at the bottom, like I mentioned, just a JSON object. So once we have these objects in here, that's when we can then either leverage third-party tools you may have in place, or we could leverage Amazon Athena to be able to query this information and actually report on it. So if I flip over into Athena, actually, sorry, one part that I didn't show quite yet. So you may be thinking, okay, we have this information in the S3 bucket, but how do we actually turn that into a database and table? And the way that we can do that is we can leverage AWS Glue, which is essentially a service that can provide ETL. So when we are working with Glue, again, this is going to be included in those same CloudFormation templates. So it would be automatically provisioned for you if you deploy the template, but it's going to take a look at those JSON objects and what is the schema within that overall S3 bucket, and it'll turn it into databases and tables for us without having to really do anything at all. So it's fantastic for me because I was never in that space before. So going over into Athena, now that we have those databases and tables built out from that S3 information, we can then just go ahead and start running SQL queries against it. Now, this query may look a little complex. Well, what I'm really doing here is just filtering out some of the information because there's a lot of detailed data that is returned within those JSON objects. But if we take a look here, if I just go ahead and run this, the real thing to highlight is that we are looking for resources that are non-compliant for patch, given a specific execution time. And then I'm just filtering for a subset of instances based off of their tags. So in here, then I can see that very detailed information. I can see the resource identifier, the account ID, the region where it resides, the classification, severity, title, all of this very detailed information that we can always work with. We can filter out more as needed or as required. And then last information is just going to be the execution time. So like I said, within that S3 bucket, there's also a wide variety of other data. So just as another example, talking about understanding what applications are out there within your environments and what applications are installed, we can use the same data set to be able to go ahead and query that. So in this case, this example is just running a simple query to look for instances that have Python installed on it. So again, I can just quickly run this query, get my information back. When you are working with Athena, you can always download the results as a CSV file. So if you do need to share that out across your organization, you can quickly grab this information. And when we are talking about Athena, I'm sure there are plenty of people like myself that are not familiar with running SQL queries. That's probably the limit of my expertise is what we see here. So if you need anything more complex, I might not be able to help. But talking about that and ease of use, we can pull in this information into QuickSight. So it's a little bit more human readable. Everyone likes pretty colors. Everyone likes seeing a dashboard. So we can integrate that data set that is provided by Athena and bring it into QuickSight to build out some visualization around it. Now this dashboard is just something that I put together really quickly. I would say I started at zero experience with QuickSight, and we got to here within about 45 minutes to an hour. So QuickSight is really easy to use, and there's a lot more things that you can do it on top of this that's not quite shown. But this is just an example of a patch dashboard, working in a multi-account, multi-region basis, being able to quickly identify how many of my EC2 are non-compliant, what is my count of missing updates, which accounts are the biggest offenders, and various other details just depending on what needs to be bubbled up. So if I were just to scroll through, populating some other information, like what are the common CVEs that my instances are currently vulnerable against? So it looks like there are plenty that need to be resolved within my environments. So the other aspects, like I mentioned, you may be saying there's a lot of different pieces that need to be set up. And that's why I was also recommending Systems Manager Explorer, which can provide that high-level overview with just a few clicks instead. So for our other side of reporting, something that is ready to go out of the box is going to be Explorer. In here, we create a single resource data sync. We can specify an account to be a delegated admin, where it's going to essentially pull in all this information for us. And when we are working with Explorer, the information that it can collect is going to be based off of other AWS services that you're also using. So if you are using AWS Config, if you're using Security Hub, it'll also pull in data from some other Systems Manager capabilities like Ops Center and Patch. Pull in information from Trusted Advisor, Support Center. So a lot of different data. If you are using these services, we can have Explorer just go ahead and pull that for us. And once we have those settings defined, then we can see our dashboard quickly available. So, we were highlighting the managed instances and patching widgets, but just as a quick, scroll through, we can also pull in information from these other AWS services like I was mentioning. So down here, at the bottom, I have, Config and Security Hub, and like I was just going to mention, you can also, move these widgets around so you can have the most relevant data at the top. And then finally, the Athena and QuickSight side of things, that's a good way to get my current state. What does my environment currently look like? How many updates are missing? Maybe I have that being shipped off on a weekly basis, or however the frequency that you may end up defining for your install schedules to occur. But like I mentioned, if we ever need to record this information for long-term retention, then we would want to ensure that we have AWS Config enabled and recording this data for us. So Config can record information for up to 7 years. It's based off of the interval that you end up defining, but it'll record this information and keep it stored so you can always go back and reflect. So if I were to pull up one of those config rules, again, the one for patch compliance in particular, we can see which of my resources are currently compliant versus those that are not. So I have a handful of instances in here that are non-compliant. And then, like I said before, you can always drill down further into this to see that recorded state. So these are all just JSON objects similar to what we were talking about earlier. But if we open up the resource timeline, that's again where we could always go back and reflect what was the previous configuration state for this resource, and when was it brought back in line, with regards to either our patch compliance or just any of those other config rules and remediation actions. Okay. So with that being said, I think we can wrap up.
So I have a question then. So you told us about deploying the event bridge cron expression to invoke your Lambda. Well, what if you had to implement multiple schedules?
Yeah, so that's a great point. So let's see if I can open this up a little bit further. So again, kind of going back into the architecture side of things, when we are working within our environment, of course, we're going to have different patching schedules. Customers that I've worked with, they can either set up schedules where their downstream accounts can then register themselves through resource tagging. So based off of these CloudFormation templates, the event bridge rule, Lambda function, as well as the automation, that'll all be compacted into a single template. So we can always just redeploy it, specify a different cron or rate-based expression, as well as target different resources as well.
Okay, so that's how you would target different resources. Say you wanted to Linux in one go and Windows in another.
Yep, exactly.
Okay. Right.
All right. So go ahead and flip back. Again, just as a quick recap, we talked about centralizing patch across our accounts and regions, the decentralized methods as well, kind of enabling some of these individual account owners to go ahead and perform patching when they need to. We went over an overview of patching on AWS as well as operating at scale, the reporting side of things using Athena and QuickSight as well as Explorer, and then through that architecture review and demonstration. So just wanted to, again, thanks everyone for attending today. Anya and I will be over to the side, so if there are any questions, if you want to talk to us further, happy to do so. Thank you again, everyone, for taking the time to attend, and I hope you enjoy the rest of Reinforce.
Thank you.